Welcome back to Retro is the New Black. In this episode, I initially wanted to show you the memory expansion, the Vortex 512K memory expansion in this specific Amstrad CPC464, but turns out the keyboard is dead. I bought this a few months ago from eBay. I have quite some of these Amstrad CPC464s around here, way too many, so I'm going to sell some off. But before I can do that, I want to repair them and clean them and stuff like that. And I intend to keep the RAM expanded version with the nice high keys. So these are the low keys and these are the high keys, but this keyboard is not working too well. But I have a second one down there with a high keyboard and also some dead keys. So I have to get a working keyboard. So that will be the first task, and then I will show you the memory expansion. So let's get right to it. So I switched on the machine. You can see that it has the memory expansion. And if I press K, I get OK. And if I press L, that works. So U, J are not OK. So some of the keys, I get more than just one key press, which could be due to a lot of dirt. And if we take a closer look at that, you can see that there's quite some dust built up in here. So we will check this first, and if that doesn't work, if we can't go and get this keyboard working, we will use the keyboard from the other one and swap it around. I did open this up before so that I could show you the memory expansion. I will show you the memory expansion in a minute. So let's do this first. These are just a few screws I have to take out. Because Amstrad, just like Commodore, was notoriously cheap, and so they just didn't put too much stuff in their machines, even screws. Are these the same length? Yo, screws are all the same length, so that is good news. There's a J down here. If anyone knows why there is a J, let me know. I guess this is from the factory. That very good. So let's open this up. We check. There are a few cables we have to remove. So let's pull this cable. It's even keyed. So this is the infamous Vortex 512K memory expansion, and it says Vortex SP512 on the side here. There are three different types of connectors. I'm not going to pull this off, but under there, let me try to show you. Under there you can see there are different kinds of connectors, and these are for the different versions of the motherboard, so that you can put this in any kind of motherboard you may come across. Yeah, it's working, you saw that. And in addition to the expanded memory, which is 512K in this case, you can get these with 256 and I think even 128. You get a basic ROM extension to work with this, because the machine itself can't address 512K, and because of that you need some bank switching mechanisms, and we will go into the detail in a minute, but that is the machine so far. So what we want to know is, can we save the keyboard? And let me show you the other side. And here is the keyboard and the data set, which is probably the heaviest part of this whole construction. And what we want to do is we want to remove this. These screws don't look stock. I never removed a keyboard from a CPC. It's just some wire which is clipping this down. You can put this to the side. That is also a ground wire, and this is some kind of ground wire. So like that, and then we should be able to unscrew this whole construction. And brittle plastic and the wrong screws are never a good combination, but let's see how far we get. Hope we don't break anything. There are also screws here. Not sure if this is a original screw or whatever this is. These could be original. So does it come out yet? No, it does not. So this might be another screw to unscrew. Yeah. Okay. Then we can take this out of here. Whoa, have one of those super gross, super dirty keyboards. Wow, there's probably enough genetic material to clone a person. Not that you need that much of that. This thing is not moving at all. I think someone pulled the spring from that one. Okay, so let's remove the keys and see what we have. Okay, let's maybe first pull those keys we know don't work, which is the J and the U. But these keys don't even have springs. Springs are inside the key. So that is not good news. What to do with this? I guess what we will do is we will actually go and turn this around and remove those plastic tabs. I hope they don't break, because if they break, there's no way to put this back together. It's only clipped in. You will be very careful to do this. This actually seems to work. I have no idea what happens if I do this. I guess we will see in a minute if all the keys fall out or anything like that. Let's just snap back into place. Ah no, I just saw these are melted in place. Oh no, Amstrad. That's not good. Because if I remove this, they will never be the same. So I guess for the purpose of this video, I will not clone a person with its hair. Shit. Quite mushy. Let me get the second CPC and let's take a look inside that and check that keyboard out. This one says key broken. 7 on numpad doesn't work. So we have at least one key not working and some key broken off, which I can't see right now. So let's open this up, take a look inside, see what we have. A nice round serial, 200, 800. So let's take this apart. Oh, whoa! It has some nice surprise inside. Look at that, whatever that is. That is what a stock CPC should look like, and that is what our memory expanded version looks like. So this board pretty much sits on top of that, and there's a connector, and you can see we have a different board revision here, where that chip is down here on my machine, down here. Other than that, these machines look pretty identical. Does look like some liquid entered this machine. And these are not here, but maybe these are just for the memory expansion. So this memory expansion is very well done. It's one of the best ways to do that. So any kind of memory expansion I've ever seen, it's very clean. Yeah, it's actually exactly the same board revision. Same copyright, part no, Z7200. Yeah. So except for these being in different places, that is pretty much the same. Interesting. Okay, so what we're going to do for now is we're going to just switch the top halves. And for now we're just going to switch the halves. So we are putting this one in here. And that should give us a working keyboard for that machine. At least working enough to actually use it. Nice. Now we should be good to go. Let's try it out. Let's see. That looks good. Cursor works, 7 does not work, like advertised. Okay, so we have a keyboard with a not working 7 key on the numpad, which is okay because we have a second 7 up here. So we don't need that right now. Good. So let's take a closer look at that memory expansion, shall we? Okay, before we dive any deeper into the hardware side of the CPC and the Vortex RAM expansion, let's take a quick look at the manual. And I have the English manual here, which is translated, and it actually says this is distributed by Screens Microcomputer Distribution in Middlesex, England. It is finally ready. Your CPC464 memory capacity may now be expanded up to a maximum of 512K. You yourself decided upon the Vortex RAM expansion, thereby selecting a thoroughly tested high-quality product which is capable of meeting your every need and exceeding your fondest wishes. Wow. Utilizing electronic components of the newest generation, that's debatable, and meticulously thought out supportive software, we have succeeded in creating a peripheral device which fits completely inside your CPC464 console. That is true. That's true. If you've discovered the basic program RAM area to be less than adequate for your programming needs, or it disturbs you to wait while your printer is busy, or you find that 44K is not enough for CP/M applications and data/word processing software, then we are sure that our product is just what you need. Solve these problems. Actually, it will solve every problem. Wow, didn't know that. So from now on, consider me problem-free because I have this RAM expansion. I'm so glad I have that. And it was even by accident. I didn't know I had one when I bought this. That is so cool. So thank you. Every problem is solved. So if you're looking, this may turn the episode into something completely different, because if you're looking for something that's solving every one of your problems, just get a CPC464 and a Vortex SP512 Ram expansion. Life can be so easy. Okay, performance characteristics. Let's check that out. Cleverly designed to fit in virtually every type Amstrad CPC464 console. Easy card installation, no soldering, just plug it in. That is pretty cool. There is actually no soldering required, which was, I guess, by almost every RAM expansion on every other system. So that is nice. Simply by plugging in the appropriate RAM chips, you can expand all the way up to 512K. No soldering required here either. Also nice, but well, that is to be expected. Just pop in more chips and you get more RAM. Intelligent onboard software assures maximum performance at all expansion levels: 64, 128, 256, 320 and 512. So you can actually pop in as much RAM as your money can buy right now and expand later. Usable with the floppy disk drive, which is also nice. If you don't have a floppy drive, you can't use this under CP/M because CP/M requires you to use a floppy drive. And well, it seems to have some kind of machine language monitor built in, some more graphics capabilities. We will check this out in a minute. So there seems to be some software which I don't have right now. This manual actually is typed on a 464 in CP/M mode using WordStar with the RAM expansion. So this manual was actually created on a 464 with this RAM expansion. It's quite cool. So here's the installation process. In order to install the RAM expansion card in your CPC464, the case must first be opened. That is kind of astounding. This requires a medium-sized Phillips or cross-tip screwdriver. After opening the console, a small flat-tip screwdriver is required for the removal of the Z80 CPU and the gate array logic chip. So these are the two chips where these cables plug in. I will show some video of that right here. The following steps must be followed exactly as worded. Don't fuck around. If your RAM expansion is to work as planned, do not omit or skip any step during the installation procedure. Turn off both the CPC and monitor as well as any other peripherals which may be connected. Disconnect all cables and connectors from the CPC console. Done. Turn your CPC over, place it face down on a towel or other soft material and loosen all 6 fastening screws with a Phillips screwdriver. Carefully turn your CPC 464 back over, ensuring that all 6 screws fall on the towel. Set your 464 down in the normal use position. Okay. Collect all the screws, putting them aside, and proceed. Gently separate the console halves, top and bottom, and tilt the keyboard toward yourself. Looking inside, you'll notice that there are 2 cable harnesses which plug into the main processor board, one at each end. We did that indeed while we switched out the keyboard. We can now look down upon the CPC464's main processor. Never good to look down on anyone. Board itself. While the various components, resistors, diodes, blah blah blah, are interesting to look at, they are, we are only going to deal with 2. These being the Z80 Central Processing Unit, CPU, and the so-called gate array. Both of these devices are of the 40-pin variety, that is, they have 20 pins on each side and are quite large. Okay, good explanation. The Z80 is located in the approximately center of the main PC board. Okay, and is mounted in a socket. The gate array is located in the upper right area of the main board, very close to the power and video connectors. It too is mounted in a socket, hopefully. A point to note about the gate array is that unlike the other chips, which may be purchased in any good electronic parts store, find one please, the array was designed and manufactured specifically for the CPC464 and is only obtainable from Amstrad. Please proceed slowly. Will do. Notice all CPC464 are not created equal. There are 3 possible component configurations for the main PC board due to the 2 different gate array types which Amstrad chose to use in the CPC464. The known possible configurations are, hey, we are really learning something here. Main board with 1 single socket for a gate array with heatsink, early CPC models. Main board with 2 optional places for a single gate array socket, which the choice of the socket placement position was dependent on the gate array used. And C, main board with 1 single socket for a gate array without heatsink, most recent model. What all this means is that the Vortex RAM expansion card has to be designed so that it would install easily no matter what model version of the CPC464 you had. Therefore, it was necessary to provide each RAM card with 2 40-pin sockets and 3 40-pole parallel pin connectors. That is a small connector on the right side. Locate the Z80 CPU, blah blah blah, put in the cable, okay, and put it in. So you have to pull out the Z80 and the gate array, put these in the card, put the card connectors in the board, like this. And here's the graphics for that. And you can see these are the 3 different mounting positions of the gate array, or the gate array cable. It is quite an interesting and clever design. Okay, there also seems to be some kind of clip attached to the card. We have to check this in a minute in my machine, because there wasn't one like that. I assume someone soldered this just in as a wire, and that has to go on this resistor right here. And properly connecting this clip will not hurt either the RAM card or the C6464. Okay. And last but important, step 15, and then come 5 more steps. Okay. Install the plastic sheet. Now reconnect the upper and lower position, blah, blah, blah. Nothing further is needed to use with BASIC. However, a new 62K system disk must be created in order to use the card under CPM. This task is handled by the cassette, which is also part of the RAM expansion package. Don't have that. When you are sure everything is in order, reconnect all cables and power up. You should see the RAM sign on in addition to the usual power up screen. And a little troubleshooting. Okay, so we should have a working RAM expansion by then. And here's a part about creating the CPM work disk, which we will not do in this video. So now we're coming to the expanded basic commands for the RAM expansion. There are 37 new basic commands to enable you to get the most out of this new peripheral without the slightest difficulty when used in BASIC. Ooh, that is quite nice. The program memory area is arranged to allow you to write 9 32K blocks of BASIC code and put them together any way you desire. Indeed, it is possible to use the same line numbers in every 32K bank, so they are bank switching. An example of your BASIC code might look like this. 120 goes up line 700, so this jumps to a subroutine, comma, bank 4. Okay, you can put the BASIC code in there and you tell it which line number in which bank you want to jump to. Interesting. So you have a printer buffer area, data memory, and a program area. You can turn the printer buffer on and off with spool on and spool off. These are, I guess, 2 of the basic commands. So these are the basic commands: bank, basic, boss, call, common, def, fast, frame, G character, goes up, go to, G paper, G pen, ID, list, load, mask. I'm pretty sure that most of these commands are already there, but they might work differently with this basic expansion. So I'm pretty sure there's a peek and poke and new and list already. All the Vortex basic command expansions begin with a vertical line. So that would be the pipe symbol in Linux, which is derived from a simultaneous pressing of the shift key and the key with a circled A, which would be the add key nowadays. Then come the different commands. Let's check this out. So we have bank as the first command, which selects a bank, one of the available 32K program memory banks. The bank can only be used in direct mode and allows the programmer to switch between banks for program input or correction. Okay, so that is the bank switching, and here are the number of banks we can switch to. So in the case of the SP512, we have 9 banks, which totals to 288K. After installation of our Vortex memory expansion card, the built-in RAM of your CPC464 becomes bank 0, while all the other banks, 1 to 8, reside on the card itself. So we have basic, which turns off the bank-oriented basic. The whole system assumes power-up condition, so it does a reset, pretty much. BOS turns on bank-oriented basic. So these are the 2 types of on-off switching. Then we have call, which can call a subroutine in machine code. Common, which is for variable definition. We have def. There you can use to list your programs on certain devices like a printer or a cassette drive or the screen. Goes up, which jumps to a subroutine. Go to, which jumps to a line number. ID. I assume you could use this to just see what kind of expansion you have. You can use this in a minute. List, that has improved to use the bank switching, so you can list from a specific bank. Load, which allows you to load programs into a specific bank. New, which allows you to erase selected or all banks of memory. So pretty much the basic commands have been edited to allow for selecting a bank. That is pretty much all there is. Now that I guess is new, where you can load 16K into video RAM or save from video RAM with screen out. That's nice. And I suppose you could do some kind of double buffering or screen switching for games or stuff like that. Spool is for the printer. A video on causes the RAM expansion card to be divided up into a maximum of 16K video RAM banks, with each bank being identified numerically. So, that is for screen buffering, so switching screens. Same goes for this, which turns it off. Yeah, then you have a ROM resident Z80 monitor, which is a line assembler, breakpoints, display stuff, fill memory, go command, load binary from cassette, list in disassembled form. So that is a classic machine code disassembler monitor thing. And then we have the expanded basic graphic commands. Interesting. We have fast. Never understood why there's a fast and a slow. If you can use fast, why not use fast? Which increases the video output speed in mode 2. You are losing the ability to window, which I'm not quite sure what that was again. We have frames, allows for flicker-free moving graphics. Okay. It is kind of a clipping feature, so that only the part of the screen is refreshed, which is redrawn. G-char reads a character from position XY into the variable var. Okay. G-paper selects and assigns a graphic background color. G-pen is the pen. Mask, define a mask for graphics output of lines and points. U-mask. Slow. Okay. So that seemed to be all the basic commands we have in here. Here's a reference card with all the commands. And you can send in your service pass. And that is it. That's the whole documentation. That whole documentation is, let me quickly check, it's 50 pages. Not quite sure what to test now. We could, of course, go to the CPC and use the new basic commands for a minute. That would be interesting. So I'm going to print these out and we're heading over to the machine again. So I did struggle a little to get this working, because it wasn't clear to me that you have to activate the basic extension. And if you start the machine, you get this screen and you just get basic 1.0. And you can do some commands like, let's say, fast, and it recognizes this. But if I do, for example, ID, which should print this up here, doesn't work. So that is very confusing. And to activate that, you have to type BOS, and that activates the basic expansion. And now you can use all the fancy basic commands that are in the manual. You can use stuff like switch a bank, bank, comma 1, bank 2. Now bank 2 is active. It always tells me which bank is active. Okay, so I tried to tinker around with the basic extensions, but really didn't get to any point. These might be interesting for some, but I think the main appeal of this RAM expansion is totally in CP/M and using standard CP/M programs on the 464. Maybe one interesting thing is this monitor. And you can use this to disassemble stuff, say from 000 to F. And then you get some disassembly. From D3000, nothing in there. Yeah, then you can assemble stuff. Start at 3000 for now, and then you can just type LD A and 65. Oh, doesn't work. And 65. LD H, A. That works. So this assembles. If we now take a look at 3000. No, 3000. We see our code. Yeah, so we have a machine language monitor, which is quite nice. You can fill an address space with values. So let's say we want to fill the 3000 range up to the 4000 range with just one value, and that would be, let's say, 65. And we now display 3000, then we have all the E's in the world. So let's quickly enter a short basic program. Yeah, that works. Now let's try if we can find this in our monitor, and let's take a look at 0170. Ah, there we have it. Okay, so that is where our basic program starts. Okay, so this machine language monitor seems to work. That's pretty neat. Wish I had that back in the day. Yeah, so I could do a second part if you would tell me what you want to see from this memory expansion. For now, it's just a huge block of memory available through bank switching, and I'm sure you could do fancy stuff with it. I like the monitor, which is quite nice, and the idea that I have the most full-stacked Amstrad CPC464 right here. But that's it for this video. So if you need to know anything more about this RAM expansion, let me know in the comments, and maybe I can do a second part and even do some programming and stuff like that if you're interested in that. So thanks for watching, and until next time. Bye-bye.
Thank you for watching Retro is the New Black. If you're new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.